So yes, I'm Lee Dunkley. I've been working in software for like 15 years now, which might be showing, mostly in the front-end space, although over the last 4 or 5 years, I've got more and more into the modeling side of systems, which is obviously what brought me to domain-driven design. And I can't exactly, tell you I'm an expert, but with the help of colleagues and meetups like this and lots of wider reading, I have learned that DDD has many, many benefits. One of them is that it can help prevent emu wars. Now, for some reason, this didn't make it into the original book, nor any of the spin-off books. So this talk is a little attempt to amend that omission. And we're going to do this in like 4 parts. So a bit of history as an analogy, a sort of little silly code example in there as well. Then we'll make that a bit more real world, but with the same kind of problems. Then we'll talk about how DDD comes in and can help us out with some of those problems we saw, and then just a tiny little summary and wrap up at the end. So you might be able to tell from my accent, not originally from here, came over about 5 years ago. And before that, I think I only knew like the classic dangerous Australian animals. I knew about the snakes, the spiders. Obviously, I'd heard about the drop bears, but to be honest, I didn't even know Australia had emus. I certainly didn't know they were dangerous. And I definitely didn't know that you could go to war with an animal. That was completely new to me. So if, like me, you don't know a lot about the emu wars, I'm going to do a very abridged history recap here. So it was just after World War I, and a load of new farmers in Western Australia were losing most of their crops to these emus. And the army was brought in to help with their cutting edge Lewis light machine guns. This might not be historically accurate there. And their goal was simply kill all the pesky emus. So with a bunch of soldiers and a bunch of machine guns, Australia went to war with the emu. Right, is there any history experts out here? Who won the war, Australia versus emus? Yes, that's right, the emus. You wouldn't guess it, but yes, the emus won this war. There were too many of them. They were too fast. They were too agile. Oh, sorry there, that was the wrong slide. I mean, they could jump over stuff. So Australia had to make do with being the runners-up in this particular war. But it wasn't just because of the strength of the emus. The Australians were, they had some physical constraints. They just didn't have enough soldiers and not enough guns. And in software, kind of like you were related to earlier, we don't really have that restriction. We don't suffer from these physical restraints. Our weapon of choice is code. And basically, we can always write more code. And, with AI and stuff like Copilot now, I'm saying it's not much of an exaggeration to say we've got near infinite code at our fingertips, pun intended. So no other industry really has this superpower, the fact that, our resource comes from here, we could just make more. So how about we go back in time and we land this sort of superpower, this lack of constraints to those Western Australians? Now they've got near infinite soldiers and near infinite machine guns. Who wins this time? I mean, the humans finally do. Finally, the humans win a war. The emus just don't stand a chance. It doesn't matter how fast they are or how agile they were. The emus are going to lose this time round. And, the bin chicken will finally take its rightful place on the Australian coat of arms, as I feel it always should have been. And by translating over this superpower of ours, this lack of physical constraints, we've completely rewritten history. Now, we'll play with this a little bit more. And instead of us giving them our superpower, let's give us, the coders of today, their problem. So you come into work tomorrow and the boss says to you, our biggest client has a problem with too many emus. And so we get presented with the goal, kill all the pesky emus. And you say, well, it sounds very weird, boss, but sure, I'll get coding. And I'm going to guess most people are a kind of OO-orientated programmers. And so, we'll say a soldier is roughly equivalent to a class, and a machine gun is roughly equivalent to a method, rather, on that class. So you start writing, you write a class, a method, you manually test it, bunch of emus in, and we've barely made a dent there. Picked off one or two, but no problem. We weren't really expecting it to work first go. We've got our superpower. We can always write more code. So we do. That original class now delegates down to another couple of fresh ones we've made, each with their own public methods again. And, we'll manually test it. And, it's better. It's definitely better. We've got a few more, but you've got to remember that this is a big problem. This is a complex problem. Although you might actually be thinking this is trivial. Anyone got any ideas of how to make this problem trivial? There we go. Just stick all the emus in a loop and be done with it. Look, it reads quite well, doesn't it? You can pass that. Right. Now, that is a great idea, but it completely ruins my hypothetical. So instead, we're going to say that this group of emus is not equivalent to an array of emus. We're going to say that each emu is representative of a particular and distinct problem. One might be hiding behind a rock. One might be really far away. This guy somehow got his hands on a sword. It doesn't really matter the nature of the problem, but it's truly complex, and that loop just isn't going to save us anymore. So obviously we're back here, and we're adding more code. And, we do a bit more manual testing, and hey, we're really making progress this time. I mean, sure, the boss, they've been looking at the calendar, seeing the days and sprints fly by, and they're not too happy with us, but that's their fault for not knowing how developer estimates really work. But we can't worry about that. There's code to be written. So you know where this is going by now. We're going to add more of it, And we're going to manually test again, and crap. So to be fair, the code base is getting pretty complex now. So we were bound to introduce some bugs. And yes, some of the emus we thought we'd got rid of them back, and some have been upgraded to T-Rexes. Apparently that can happen. So we've got to investigate those bugs, and the boss is really staring daggers at us. Does this sound familiar to anyone so far? I mean, other than the emus, hopefully. But we're going to pull through, maybe even do a late shift or whatever, and add more code, and we'll manually test it, and hooray, it finally works. And obviously, neither the boss nor the client see all that code that we put our blood, sweat, and tears in. They just see this black box. So we don't feel 100% appreciated that they know the pain we went through to get them a working solution. But, who cares? It finally works. Except we need to get it past code review. And this sort of pseudo class diagram, very pseudo class diagram, has been giving a very zoomed out view. You've got to remember that a couple of sprints have passed by now. So this PR is big. It's going to be, 2,000 lines or so. I mean, how many people is that big? Was that small? I hope that's not small to people. I did wonder when I was picking this number. Sound reasonably big? Yeah, you're not looking forward to it. So when we find some unlucky reviewer to take a look for us, they're bound to just find a few typos. They might find a few emos. Maybe they'll find an Elmo for us. But really, it's all very complex. It's thousands of lines. They've got their own code that they'd rather be writing. So obviously, they'll give it the 15 minutes, and they'll be ready to give you the looks good to me. When actually, just before they do that, they notice we haven't put any tests on it. So obviously, we're good developers. We can't not have tests. So begrudgingly, we'll start adding them. So a test for each class, where every other class is fully mocked out, and we're just asserting that the methods output whatever they currently output. But who cares? We've done it, yeah. So unlike in the real world, with our superpower of near infinite code, we've won our digital emu world. The thing is, though, you could stop and ask, at what cost have we won it? Because if you remember, our goal was kill all the pesky emus. And really, we kind of need to test at this scope to prove we've actually done that. And we're just testing at these other scopes, these lower scopes, which mock out everything else. So have we proven that we've killed all the pesky emus. Well, sort of, but yeah, not really. Also, the code base is really complicated. No, our reviewer, they gave up trying to understand it, and we understand it right now, but give that a few months. It's been a rough few months. And if we think about the boss and the client, well, they reckon we took far too long, and we're dreading the day that they find more bugs. What happens if the problem space develops? Maybe a couple of the emus learn to ride a skateboard, or one of them invents the flamethrower. Refactoring this code base to meet those new problems, nobody's looking forward to that. So, sure, we've sort of crushed the problem under an avalanche of code, but what does it cost us? Well, I'm going to argue it's cost us maintainability, and it cost us extensibility. And at this point, you might be wondering, wasn't this meant to be a domain-driven design talk? Because all we've ascertained so far is that emu wars are, in the real world, unwinnable. In code, they're winnable, but unmaintainable and unextendable. And that would be a fair point. So in part 2, we're going to move and add, move to the real world a bit more and add a proper domain. Not just any domain, we're going to add the ubiquitous, pun intended, DDD presentation domain of e-commerce. And so let's say it's an already established e-commerce store. There are various APIs for the shoppers to view products, add them to the basket, to pay and to check out. And there's APIs for the store manager where they can view customers, see incoming orders, and set them as dispatched. And this all works fine. Every day money goes from here to here, and goods go from there to there, and everyone's happy. And backing it up, let's imagine we have a whole bunch of microservices, because microservices are cool. Yeah, right. So anyhow, you come into work tomorrow, and the boss says, the store manager needs to update orders. That one sounds a lot more reasonable, doesn't it? So you say, no problem, boss, I'll get coding. So you write a class and a method, and maybe that method is wired up to whatever web framework of your choice is, taking in that update order command, and probably in that class somewhere, you're reaching out to a database, changing stuff around, putting it back. And again, we're going to keep things simple for this presentation, and we're going to take things like authentication, permissions, security, and logging. We're going to take all of that for granted, not that we would do that in the real world. And at this point, we've basically coded up our update order API. So we manually test it, and it works. And not only that, we're going to add tests straight away. And the PR is fairly small, and it's quickly approved, and we deploy it, and the boss is happy. A bit of a different story now. Well, until time passes and they come back to us. Now the boss is unhappy because there's a bug. And this bug is that some shoppers receive too many items. So you go, okay, I'll look into the code. But you don't see anything obvious in the code that would actually do that. So you look at the logs. And here, as we often do, we find a pattern. So the bug seems to occur when the order is updated to have fewer products. But that's happening after we already okayed the order for dispatch. So the customer receives the original amount of goods and not the updated reduced amount of goods. Right, so obviously there's only one place to fix that. We're back to the code, and we're going to have a few more classes, and we'll try and handle this issue. So maybe this guy is reaching out to that shipping microservice and finding out if the order's already set as ready for dispatch. And if it is, then well, this guy over here might encapsulate a 400. You can't update an order after we've already marked it ready for dispatch error to give back to any client trying to do it at this point. And I know that sounds a bit much for a class, but this isn't meant to be one-to-one with code. What I'm illustrating here is more responsibility, more code. It's got to go somewhere. And so our code base is growing. And anyhow, you do some manual testing and it works. You add your new unit tests to those new classes, get a pretty quick code review, and you tell the boss, yeah, it's fixed. You deploy it and they're happy. And they find another bug. Some shoppers are now being undercharged. Now, obviously, at this point, We are a seasoned developer. We still remember the last bug. We're going to go straight to the logs this time. It's bound to be another race condition. And actually, we're right. So there are updates to the order that add new products happening after the payment is already captured. So this time, the shopper is charged the original lesser price and not that price that takes into account those new items. And of course, this is where we come back to the code. And we're exercising our superpower and we're adding more classes, more code to deal with the problem. And maybe this guy's reaching out to the payments microservice and we're checking if payments has already been captured. And if it is, then yeah, we're going to have another 400 error saying you can't add items after we've already taken payment. And, you know, our old friends that we had a minute ago now moved over here, and maybe we've got a few other classes and bit of code to help tie all of that together as we've got a few scenarios to manage now. And we'll do some manual testing, which takes a bit longer because we've got more scenarios to keep in mind. A few more unit tests, which takes a bit longer, which is also true for the code review. But eventually, we get it through. And we tell our boss it's fixed. We deploy it. They're happy until, oh, no. I mean, these things come in threes, don't they? There's another bug. So some shoppers receive empty boxes. Now, this one, when we look at the logs, there's nothing obvious. Like, why empty boxes? And check the code. And again, there's nothing in your beautifully handcrafted code that would result in empty boxes going to customers. So you see nothing obvious there. And it's only actually when you overhear the boss saying it only seems to happen with cancelled orders that you remember that there is no cancel order endpoint. The store manager has been using your new update order endpoint to gradually remove all the items from an order. But unfortunately, the order, in a sense, still exists. And our heavily automated warehouse honors that order and ships it on out. And again, at this point, you might be thinking that's a very silly, contrived example. And I can tell you from personal experience, that definitely can possibly happen. Anyway, we're back to our code, and obviously we're adding more code, aren't we? And this time, you know, we're keeping an eye on, you know, they're removing items. So once they remove the last item, maybe we'll invalidate the delivery information in some way. And, you know, that will end up with boxes in the warehouse. The warehouse doesn't know what to do with, but at least we're not shipping them out. So we'll count that as a win. And maybe at this point, you know, we've reached for the old design patterns book because we're fully conscious that this is becoming quite a complicated code base and we're well-meaning. So we're going to make that much better with a few clever patterns. And again, we're manually testing. We're adding unit tests, going through code reviews, which is now taking forever because of all the complexity and all of these mounting scenarios. But eventually we tell the boss it's fixed, we deploy it, and they're happy. Dramatic pause and swig of water. Time passes rather, doesn't pause, it passes. And oh, don't worry, we're actually good. We're actually good this time. So there is still the occasional race condition where an update happens at the exact same time as, say, a ready for shipment event or payment being captured. And there's the thing in the warehouse where there's some empty boxes mounting up. But they're rare enough that nobody really cares. They don't want to invest any more time in this. It's good enough. And going through this, you may have noticed that my silly pseudo class diagram looks very familiar. Now, I swear, this isn't just lazy illustration. What it actually was a heavy-handed attempt at clever foreshadowing. I'll take that laughter to mean it worked. Because just like our code base with the Emu War, we kind of solved our update order problem with an avalanche of code. And again, if we ask ourselves, well, we solved it, but at what cost? We're going to get a similar answer. You know, our problem was the store manager needs to update orders, which again, in all honesty, we'd have to test at one of these outermost scopes to really prove that we've satisfied that. And, you know, this is even trickier in this hypothetical because we've got all the I/O of databases, the in-process calls to other microservices that maybe we shouldn't be doing. So we've probably got some happy path tests, but Mostly, we're just testing at these lower scopes, which basically mock out everything else. So are we proving that update order completely works in our test? Well, kind of again, but yeah, in all honesty, not really. And again, the code base has ended up very complicated. This time, though, we did get it through the code reviews because we kind of split them up into chunks, and our reviewer managed with that, just about. But how about a new starter? Unfortunately, they're not going to get that nice incremental view of our code. They're going to get it all at once. And how about ourselves in the future? You know, when you're paged at 2 a.m. in the morning and having to remember what the hell you wrote 3 months ago. I mean, it's also going to be remembered as a slow project with plenty of bugs, and it's a code base that nobody is really looking forward to extending. So I'm going to say that just like before, we've kind of crushed the problem under an avalanche of code again, and it's cost us maintainability and it's cost us extensibility. Now, it's often at this point we tell ourselves things like complex problems require complex solutions, or you can't remove complexity, you can only move it around, as a way of sort of absolving ourselves a little bit. And to be fair, for the vast majority of my career, I have definitely been saying those things. And I think this is where domain-driven design finally comes in and sort of helps question a few of those assumptions, and in doing so can help lead to a much nicer code base. And where to start, but obviously with event storming. So, you like that one, did you? Started? You seen that one before? Right, so we're going to quickly whiz through and put the events up that describe that sort of e-commerce solution, but prior to update order coming in. So products will be listed, they'll be viewed, added to cart, delivery address will be added, payment details added, payment authorized, order submitted, we'll reserve stock, capture payment, confirm the order, send an email, sometime later, pick the stock, and finally ship that order. So I'm not saying here that our solution is necessarily event-driven, but the events nonetheless actually exist. They just might be implicit in the code. So now, with that in place, let's sort of replay this problem statement we were given. So the store manager needs to update orders. Obviously, if you just stick the past tense on that, you've got order updated, an order updated event. Again, sounds fair enough, sounds reasonable on the face of it. And where's it going on a timeline? Well, obviously, it can't go before the order exists. It's got to be sometime after that. Maybe just after the order was submitted, or after stock was reserved, or actually it could happen after that. Also there before the stock is picked, I guess, and even up to the point that it was shipped, technically this event could happen. And in fact, well, oh dear, look at them go. This kind of points out that they can happen at the exact same time as some other very important events in our system. And if we think back to those bugs we were fixing earlier, for example, when the shopper received too many items, the fact the order could be updated at just about any time was the underlying cause. And the same was true for the undercharging bug. So in that case, an order was updated to have more items prior to it being shipped, but after payment was already taken, hence bug. So clearly there is a bit of a modeling smell here. Oh, I clearly enjoyed that more than you guys did. And I would say that that smell intensifies when we look at the language that we're using. So if we plot our verbs on a scale from specific to hopelessly generic up there, you know, picked, add to cart, sound very e-commerce-y. Reserve listed, well, there's a few domains that could pop up in, but, you know, still good enough. Added, viewed, yes, we're getting pretty generic now. But yeah, updated, yeah, I'd say this is very much in the danger zone. It's hard to think of really a digital representation of anything that couldn't be updated. Phones get updated, games get updated, even relationship statuses very occasionally get updated. And if you think about it, it doesn't really convey much intent, doesn't signify any intent from the store manager. I I mean, if we went and, fiddled with the date modified field in the database, is that good enough for order updated event to be fired? But I guess that was our brief, yeah? Our brief was the store manager needs to update orders. And this is where I have to come clean and tell you that I missed a few important details out at the start of the presentation back when I was talking about the emu wars. So I presented that problem statement as kill all the pesky emus, yeah? Which is kind of true, but it's not the whole story. And if you remember, that goal existed because the emus kept eating all the new farmers' crops. And they did that because these new farms were set up along long-standing emu migration routes. Yes, it sounds like a clever idea, doesn't it? So why the need for these new farms and why on these less than ideal spots? Well, actually, it was to give returning soldiers from World War I employment. The government was giving them land for them to become farmers, for them to become self-sufficient and have employment. Now they've left the army. So in reality, the goal was never actually kill all the pesky emus. That was merely an implementation detail of a possible solution to the real problem of how to provide returning soldiers with employment. So as well as not being able to profess myself as a DDD expert, I'm also not an expert in the job market of the early 1900s in Australia. It may shock you. But I think it's fair to say that there probably were other solutions to this problem, and I'm sure none of them would have been perfect, but I'm also very confident that none of them would have led to the need to start an unwinnable war against an army of 6-foot-tall birds. Now, with all this in mind, I'd argue that we're kind of doing the same thing with our update order scenario. That all of that code complexity, which was mirrored in the event storming, the poor testability and all those bugs that resulted, the evolutioning language and that picture none of you liked, or modeling smells, we're all trying to tell us and trying to indicate that update orders was another implementation detail masquerading as a problem statement. In fact, this was just another emu war. And if we think back to our bugs, the store manager never really wanted an arbitrary update to an order. When the store manager was removing products, it was to ensure shoppers only receive and pay for items they really want. When they were adding items during an order update, it was to allow shoppers to easily receive extra items that they had forgotten. And when they were removing all of the items in an order update, it was to give shoppers an easy way to back out of an order. And you'll notice that nowhere in these problem statements do we use the word update. So a key takeaway here is not to accidentally put implementation details in your problem statements. At worst, they become self-fulfilling prophecies, as we saw there. And at best, they just restrict your creativity in problem solving. So let's go and delete our update order API and start fresh. And if we take each of those new 3 problem statements one at a time, maybe we'll start with allow shoppers to easily receive extra items that they forgot. Without update order in the definition, there's probably a ton of ways to solve this problem. The shopper would probably be completely happy with the store manager instantly turning up at their front door with the forgotten items in hand and a card reader in the other. The store manager, though, might prefer we solve this problem with code. And to do that, we could just imagine a new place supplementary order endpoint, which would take a reference to the original order, a list of the items and quantities that were forgotten, and give you out a brand new order with little bits cloned from that other one, and probably a reference between the two as well. And before writing any code, we can sort of sense check this with going back to our events. And the nice thing here is, regardless of where we put it, all that creating a supplementary order does is create a brand new swim lane of events which carry on in isolation just like any other order. And what we've avoided here are events that contradict or undermine other events that came at the same time or before it. Which we can already tell means fewer calls out to other microservices, far fewer branches in the code, so it can be more ignorant and decoupled from the wider system, which should also make it easier to review and test. And that's just one potential solution to this problem. There are probably better ones out there. But hey, how about these two? You know, they're a bit more problematic. How can we solve them, again, without ending up with the fighting events and the rewrites of history? Well, has anyone seen this before on Uber Eats? So I've ordered my delicious sushi, which is going to auto-confirm in about 10 seconds. But until then, I can actually back out if I want to, which is just off screen there. But I swear to you, there is a back out button. Or how about this? So you're sending an email, you press send, and you're given an opportunity to undo. Oh, damn, it's down off the screen again. Hopefully online you can see this. In person, we've got a projection screen that is just a few inches too short. But down there, again, take my word for it, there is an undo button. Now, how do you undo an email? Does it go and delete it from the recipient's outbox? Well, what actually is happening in each of these cases is that the system is telling me that these events have happened, but it's only after a certain amount of time that they're made public to other services, other systems, and the rest of the world. It's only then the rest of the world finds out these things have happened. And maybe we can use the same technique here. So luckily in e-commerce, buyer's remorse kicks in very quick. I'm sure you've all experienced it yourself, but the moment after you actually put in your payment details and press click, you go, oh, actually, I didn't need two of the exact same T-shirts. Or maybe worse, you were buying film tickets and you wanted to go see Dune 2, and you accidentally bought tickets to see Madam Web. The horror of that accident is going to kick in the instant you see the order confirmation. And we can kind of take advantage of the speed of buyer's remorse here. And if we think back to our books, things kind of went wrong when we took payment or shipped orders based on out-of-date information. And if we trace back the processes that triggered each of those events, we'll eventually hit order submitted. And that's kind of the guide we want to keep quiet. And we can imagine doing that, much like Uber Eats and that email client did, if we just make room for a new order received event and maybe a back out period expired event. And a typical order would just progress along these as normal. Tiny little time delay in the middle, but nobody's going to notice that. But should a shopper, want to back out entirely, or just turn their order back into a basket so they can amend, take a thing out, add a thing in, there's now a safe window in which they can do that. So if you think back to the update order way of solving this problem, the moment the order was updated, there was a huge blast radius of events it could have effectively contradict and undermine, leading to a lot of complexity and bugs. Now back to this new solution, we've got a much smaller blast radius that doesn't really seem to undermine anything. So the events that would have followed it simply never happen. Now again, this might not be a perfect solution. There could be better ones out there. This is just, us developers spitballing ideas. Really, we need to get together with our domain experts and hash out these possibilities and make sure they're the right fit for the business. But for argument's sake, and as I've probably only got 10 minutes left, we'll say that these solutions are good enough. So let's imagine we ran with them, and our complex and buggy update order solution has been replaced, partly by a very simple place supplementary order endpoint, which allows us directly to reach that goal of allowing shoppers to easily receive extra items that they forgot. And on the other side, we've got that small split in our submit order logic of introducing that order received little gap and that chance to cancel with the new cancel endpoint, and that back out cron job that would otherwise progress the order out for us. And both those two come together to satisfy the goals of give shoppers an easy way to back out of an order and to ensure shoppers only receive and pay for items they really want. And again, without diving into the code, it's fair to say that each of these is a bit more single purpose and a bit less complex than what we had before. And this is where, if we revisit our old truisms of complex problems require complex solutions, I would argue we can now benefit from the other side of that same coin of simple problems only need simple solutions. And we kind of were able to get there because domain-driven design has helped us get around this guy You know, you cannot remove complexity, you can only move it around. Because with our DDD hats on, that's how they look. I think they're in the gift shop. Yes, yes. We can see that this is true, but it does need some amendments and a few asterisks. So you can't remove necessary complexity from your current level of abstraction, but go up a level because maybe you can remove some of the complexity from there. I can see you all like that. So yes, it is horrifically uncatchy, but it does provide a decent overview of what I believe we've achieved in that e-commerce example. But maybe a visualization is better. Oh, you see, you're missing a pun here as well. At the bottom, instead of saying time left to right, it says how long you've been sat there. You see, thank God you've got imaginations to make that joke work. So if you recall our sort of pre-update order version of the system, we kind of start with we'll call that mental model version 1. Then that problem statement came along of the store manager needs to update orders, and that kind of spawned a version 2 of that mental model, which kind of straight away went down into code, and we built the update order endpoint that requirement basically willed into existence by its very wording. Obviously, we didn't like that, and with a bit of thought, a bit of event storming, some of those domain-driven design practices, we sort of came up with a new mental model where we split that very vague, very inaccurate statement of I want to update an order into three very more specific goals. And by doing that, when we return back to what I'm calling the code level of abstraction, we had way less complexity to then fulfill in code. So I'm going to argue you can actually remove complexity. And really, this is going to be one of my favorite things that sort of domain-driven design has opened up as a possibility to me. So often if you, you align your solution space more closely to the problem space, a whole bunch of this complexity can evaporate. Now, how on earth do I wrap all this up? So unless your domain is either e-commerce or the early 1900s Australian job market, I didn't hear that one yelled out for you earlier, so maybe just some of the quiet guys are working on that. So in that case, the technical and modeling solutions I've shown probably are of no real direct value to you. However, what I do hope you might take away from this talk is a potential way to prevent your superpower from becoming a bit of a curse. And that the next time you find you're either yourself or a colleague 6 classes deep in a problem, which is full of complexity and maybe a few bugs, rather than crushing that problem under an avalanche of code, you recall this silly talk, maybe you'll reach for domain-driven design, do a bit of event storming and check your ubiquitous language to make sure that you're not solving the wrong problem in the first place, and to make sure that you're definitely not fighting your own unmaintainable and inextensible emu war.
Very good.
Thank you very much. So that talk was very high level. And if you want something that gets you from like event storming all the way down to code, I very strongly recommend this talk by Michael Plod. It is fantastic. I strongly recommend that. And if nothing else, I hope you enjoy the illustrations. The QR code is a little off there, but the website might be there. Done by my better half. So yeah, she gets the credit for it actually looking like a good presentation, if not sounding like a good presentation. Thank you very much. I could attempt to take questions. Anything on the illustration, I will just pretend.
Talking very bit about strategic design is really the main thing.
Mm-hmm.
So people getting training, you need to train your business experts on the concepts of strategic design.
Well, I guess, or as much listen. I mean, the main part of the talk is if we possibly listened to that store manager at the start, we probably wouldn't have built that silly update order because it wasn't aligned to what they wanted. You know, partly the talk is more about listening the other way, really. Yeah.
Yeah, so the history of software development, you go back to say, also working bits and machine language. So is it? We're continuing sort of simplifying complexity so that we can work at manage higher levels
Mhm.
of complexity,
Mhm.
right? And whether that sort of be, say, quite often it's sort of higher levels of abstraction, right? Say design patterns or design DDD, sort of opinionated frameworks that allow us to sort of the solution, the problem space or the solution is so much closer to the solution space, or working with cloud so that we abstract away all the physical, the networks and things, so that we can treat that as a logical. So our focus is on what actually delivers business value to the users, which is the logical part, because then any application that's sort of the logical has got to sit within a physical framework that sort of makes it happen. But sort of increasingly, sort of we're sort of working at abstraction level, so we sort of manage all that physical complexity, so that developers become a lot more productive.
Yeah, I mean, we can now stand on the shoulders of giants of those frameworks and those abstractions that we don't need to write ourselves. So I don't need to, as a front-end guy, I don't need to invent React. It already exists for me. So I don't spend my life working with how horrible domain events work in the browser's term. I can instead listen to what my user wants and focus on that problem, because so much of those common, domain agnostic problems have been abstracted away. So we're lucky in some sense.
Yeah, and probably AI, so we're only at the beginning, so we're sort of still discovering how to use it and all the benefits. Will probably sort of provide us a means of sort of another jump in sort of abstraction levels in solving and problems and producing solutions for the future.
Yeah, quite possibly. I mean, it sounds like you've got a case for a new talk over there. AI in domain-driven design.
I was actually Explore DDD conference recently in the US, had Eric Evans talking about avalanche. So you're on a hot topic. You want to do a talk? We'd love to have it.
What about phenomenological
Software. If I can remember how to say it. Cool. Are we got any questions online? I think someone had to.
Would you create one API with its own DB for each of your use cases, or do you have any advice when multiple use cases share endpoint and DB? Well, I guess the DB will be getting more into the nitty gritty, but sharing an endpoint is kind of one of the root problems in the talk. Was some developers may look at what I proposed there of having, three ways of solving three distinct problems and go, oh, I could dry that up and give you one endpoint that does it all. And we'd be back to that update order endpoint that tries to solve for everyone and thus solves for no one. So I certainly wouldn't recommend doing that at the interface, because there you want to be as close to the problem space as possible. So if your user thinks of multiple actions as separate, and I wouldn't do A when I was thinking about B, then don't merge those things together, is what I'd say there. Whether it makes sense at a DB level, I think we'd need to get way more in the nitty gritty to say anything about that.
I'm real DDD units, and I wanted to do some abstraction. No way you can let me do that, to abstract that. They used to love the fact that it was separate code, it was directly separate.
Excellent. Well, thanks so much. That was absolutely amazing. Probably our first combo DDD stand-up comedy talk. Excellent. Well, that brings us to the end this evening. Thanks very much, everyone who joined us online. I see there's a raised hand. Shruti.
Yeah, my question was more
Nobody can hear you, sorry.
towards. Can you hear us? Can you hear me?
We can now. Yes, please go ahead.
Okay. My question was more towards if we have implemented a solution, and I think I may also have been, part of this whole go fix the code problem earlier on in my career till I realized this is just a never-ending loop. But the very first knee-jerk reaction would be there is a bug, let's go fix it, and we need to deploy it. But when you're in such a situation where you have a bug, how much of time would you get to go back, analyze as to, can we go back and figure out what exactly the client means and not what he's telling us to do, and then work our way backwards to, get those three, in this case, get those three different events in place. Like you may not have implemented your solution in DDD in the first place to start off with. So how do you go back and correct it?
Just inviting Lee back up just a second.
I mean, it's at this point I wish I'd fully read the refactoring book, because I mean that sounds largely like the problem you're describing is a problem of when can I refactor back towards a better solution, and that is a tough one because obviously it's something you've got to talk to your business owners about, and when is a good time, how much time investment can you give it, is way more of a product decision in the end than it is a developer's decision. However, it is a bit of a mistake to keep kicking that can down the road, because when our new requirements and features come, they will come from users very much under through the lenses of how they understand the problem space. So if your code is not embodying that, then you will find more and more when they ask for a new feature or a new change, you're going to go, oh crap, this is really hard. It's as if they're asking me to completely break my code base. And that is eventually why we all go, it'd be quicker to rewrite it from scratch. So I don't have a good answer for you, because this is a industry-wide, massive, horrible problem of pick your poison. I think it is something that us as developers, we can do sometimes a better job in explaining to product owners the costs and the risks of not moving closer to a better solution that better aligns with our problem space, because it will only snowball, and it will eventually hit that critical point where somebody does eventually get the remit to completely rebuild the thing from scratch. I guess with that in mind, if you've got anyone in your company who has suffered through a potential rewrite that never happened or failed, maybe bring that up and threaten them with it and say, give me the chance to do little refactorings as we go to get closer to this better solution, or you're doomed to repeat history and we'll have a failed rewrite in 3 years. So I know that's not super useful, but I don't think there is a silver bullet for that one.